We're going to finish up our vector work by getting dangerously close to doing some physics problems. As I've told you before, physics makes my brain melt, so we're not going to go very far into these word problems. But I do want to try to tie all of the mathematics that we've done concerning vectors into some of the work that you're going to be doing in physics. I don't know how helpful this will be, but we're going to make an attempt to see if we can tie everything we've been doing together. We're also going to tie some work that we did prior to the vector work, the law of sines and cosines, into some of these word problems too, because you'll see that they'll pop up in some of your vector work as well. So let's work a couple of examples where, again, we're not going to delve very deeply into them, but we're going to try to see if we can draw ourselves a picture and see if we can figure out using vectors and using law of sines and cosines or other trig relationships that we know into working some of these word problems. So here, a plane is heading 34 degrees west of south. Now we would call that southwest, but west of south helps us when we're in the plane if we think of the y-axis as the north-south axis and the x-axis as the west-east axis. So when we talk west of south, that we know that puts us in quadrant 3. So after 240 miles, and you can see we have that drawn here. Here's this first vector. We can see it's 240 miles and that it was traveling 34 degrees west of south or southwest. The pilot changes his direction to 78 degrees west of south. So here we are after 240 miles. We have a new angle that is 78 degrees west of south. And then he travels another 480 miles. So there's a second vector. And we can see with vector addition that results in vector r. So find the distance and bearing from the starting point. So in other words, find the vector r and the angle theta. So here's the angle that we're after. Well, you can see that we have found the distance, the length of vector r, the magnitude of vector r using the law of cosines, because we know one angle measure here, we know another angle measure here, so we can find the angle measure between them. We know two sides, so we know side angle side, and that speaks that we need to use the law of cosines. And so we can find the magnitude of vector r using the law of cosines. And now we have angles and we have side measures, all three side measures, so we can jump to the law of sines to find the measure of angle theta. And so here the measure of angle theta using the law of sines is 29.67 degrees. So we have 29.67 degrees, we have 34 degrees, so the angle bearing is 63.67 degrees, and the distance is 673.60 miles. So we have to pull in a lot of mathematics that we know. And again, my argument is drawing a picture is going to help us do all that. Let's work a second example. A clown is shot out of a cannon with a velocity of 200 feet per second at an angle of 24 degrees with the horizontal. Find the vertical and horizontal components of the velocity of this clown. Well, if we draw ourselves a picture, we know that the angle is 24 degrees. We know the velocity is 200 feet per second. We want the horizontal component and we want the vertical component. Well, we can find the horizontal because the cosine is adjacent over hypotenuse, and we can find the vertical because the sine is opposite over hypotenuse. So we just find the cosine of 24 degrees and solve for x, and the sine of 24 degrees and solve for x, and we have a vector, this vector that has horizontal component 182.71 feet per second and vertical component 81.35 feet per second. Now there are many other types of word problems working with vectors. These are just two kind of straightforward ones that tie us back into our trig work and tie it into our vector work. The homework's not going to be terribly complicated, so come to class next time and we'll work some homework problems that are word problems with a vector setting.